it has just occurred to me that the piston component of Tesla's special generator, as told to us by Thomas Comerford Martin and promoted by William Line, so that we might know about something that not too many people would, who heard of Thomas Comerford Martin. It occurred to me that the piston serves as an electrostatic discharge by way of ionizing the compressed air that flows across it. It's exactly like the aerial on Tesla's Pierce Arrow, and it's exactly like the chassis versus the aluminum brackets underneath the rotor coils of the EV Gray motor that Richard Hackenberger had engineered to avoid electrostatic buildup, in which prior they had used batteries to sink the excess electrostatic charge into, and they were blowing them up. But they were also radio broadcasting interference in their local environment, and that's why the FCC raided them a second time. This is the EV Gray team in the I believe it was in the 70s. They had two raids in the 70s, one in the early part around 74 and one later on, unless the second one was in the 80s, but I don't think so. The DA's office headed the first raid. Anyway, so it's a perfect situation because we got air, compressed air, flowing across a metallic object. So, where does the electrostatic charge come from that it should build up in the piston? Well, first of all, it's on a shaft, and the shaft is at right angles to the magnetic flux of the two horseshoe pieces constituting the two M coils of Tesla's special generator. Being that it's at right angles, I have to assume that the electric field is naturally going to want to charge it up without any effort on anybody's part. It's already set up. So the electric field is terminating on the 4 feet of the two horseshoe magnets, and the shaft that the two pairs of H coils are on is short-circuiting it, even though the shaft doesn't go anywhere. Okay? Now, where do the coils go? Because they're part of the shaft, the electrostatic field of the shaft. So the H coils is the electrostatic field, the electric field, and the M coils are the magnetic field. And so the M coils are the field coils, too. But it stands to reason that's why the H coils do not require a whole lot of windings. And it might also require why they are counterwound, because counterwinding would neutralize amperage, and amperage is magnetism. So if we just want an electrostatic field to build up, they'd have to be counterwound. Okay? And in order to prevent amperage from flowing through the H coils, they just might be self-looped, so that they're merely there to build up a charge, an electrostatic charge, and hold it on behalf of the shaft that they are sitting on, because somebody's got to hold it. Now we have a varying electrostatic field because the piston is reciprocating, pushing and pulling the H coils in and out of the magnetic flux in the gap between the 4 feet of the two horseshoe magnets, powered by the M coils. And we have the M coils constituting a magnetic field. So where would the electricity synthesize? And in what form? And what do we do with it? So, if it's being synthesized in the H coils, so what about it? Who cares? But if it's transferred to the shaft, that the piston is attached to in the middle. Then it has to make it stands to wonder. It has to make you wonder: is the shaft connected to anything? The bearings that the shaft is sitting on, is that the connection point? That's kind of has not been in our focus, not explicitly pointed out to us. All it takes is two connections, one on each set of bearings on either side of the holding the shaft. That would be its own loop, and would, unlike part 2 of this video series, this is part 3, it wouldn't go anywhere else. I thought it would go through the M coils via the hull, but why should it? Why bother? It may just go back to the other set of bearings on the other side of the device that the shaft is sitting on. So the bearings are acting like brushes, in a sense. And instead of a revolving drum, we have a reciprocating piston instead. This is really odd. In a choo-choo train, we have pressure building up in the steam boiler, powering the pistons that they drive in a reciprocating fashion. I would guess that the reciprocating pistons are building up an electrostatic field charge of their own, which are grounded to the chassis of the locomotive at the head of the train, which is charging up the boiler. It's hard for me to imagine that the H coils are connected to anything outside themselves, because they're counterwound. What good would that do? I have to assume, because there are all these different segmented components of the circuit, and since I have to rely on intuition, I have to take it on faith that every step I take, intuitive step, has to be taken on faith that it's valid, even though it doesn't make sense at the time. Doesn't matter. It's like any good movie where the investigating person is trying to unravel something and it's composed of various parts. They literally fly by the seat of their pants and take it on faith that every part is valid. And that's the only way they were able to make any progress. So I have to assume that the H coils are counterwound in pairs, and each pair is looped to its own pair. But I never thought the shaft would be part of any kind of circuit, and that would constitute the third loop, with itself and possibly the load. Which is interesting because we already have a galvanic situation going on, because we got a brass centerpiece, 2 aluminum rods, and then 2 more brass pieces, I bet, outside of those that slip through the brass bearings that hold this entire shaft. So the shaft is made of 5 segments, metallic. So there's going to be some kind of galvanic response between aluminum and brass, something I'd have to look up. What's the electronegativity between them, what kind of voltage. So we've already got a weak battery going on here of its own, and corrosion in the joints between them, which would create either a diode situation or at the very least resistance. Whether or not the resistance is only in one direction and not both directions, that remains to be seen. But at least it would have resistance of a type, or resistance of a vector, or 2. 1 or 2 vectors, bidirectional vectors. Which is important, because when you've got a free energy device, you always want to put in, what do they call it? I don't know, for lack of a phrase, I'll make up one, an idling load. It's a non-varying load that has to be there to safeguard the system from blowing itself up or not functioning, because the load has to be there to make it work. Now let's see, we've got 5 segments. How many junctions? Let's see, 2 junctions around the middle, brass. 2 more outside the aluminum pieces. That's 4. They're going to be an even amount. So they neutralize each other. So the whole shaft is based on neutralization of polarity. The galvanic junctions and the counterwound pairs of H coils. So what's the point? How can you have that drive oh, wait a minute. He didn't use it to drive a motor. Aha. He used it to charge a battery. Now Newman, yeah, I always felt that this was similar to Newman, except more sophisticated. Newman would dispense with everything except just one of those M coils, and that would constitute a large part of his motor. But now that I know from Byron Brubaker, there's a helium canister in the middle, which everybody thinks is a solid magnet, solid permanent magnet, but it's not. It's a hollow permanent, or it may not be a permanent magnet. It may just be a hollow magnetizable vessel filled with helium. It has some kind of special contribution to make. To boost, right, to boost the magnetic. So it's like a super magnet. I wonder if you could replace it with a Neo and it would be just as good. Maybe not. Maybe not. Anyway. And I'm assuming that Tesla did not use a hidden helium canister inside the piston. There's the copper surrounding what would have been helium. God only knows what's going on here. Wait a minute. Who said it has to be liquid air and compressed air feeding this thing? What if it's liquid helium? Well, I think that has a lower precipitation point than liquid air. Liquid air is probably higher because of the major component of nitrogen in air. Helium probably has a lower, I think most people call it a boiling point, but in this case I would just prefer to call it precipitation from its gaseous state. This could be very interesting. What if it was helium blowing across? Oh, then you don't need helium hidden on the inside because that's on the outside. Holy moly. Does that mean all of the, if it should leak, all of the crew members on board the Electro U-boat would start talking like Donald Duck or something? Or, no, Alvin and the Chipmunks? Oh my god. Isn't helium laughing gas? No, that's nitrous oxide. Helium. Well, helium's going to make the whole thing want to float like crazy. It's going to have to carry a lot of dead weight just to stay underwater. But liquid helium, of course, won't act as a ballast. Oh, if they... Helium. Well, it's a noble gas. That means it won't interact. It's stable. Chemically. It won't chemically interact. Which is probably why it has a electromagnetic contribution to make, because it is so chemically stable. That might be true. Oh no. Didn't Stanley Meyer talk about the use of noble gases? Unbelievable. What does that have to do with water, though? Oh, no. Yeah, but... what if we misunderstand Stanley Meyer and he'd never combusted anything inside his dune buggy engine? He just blew helium through it. And it was the gas mixing tube, toroidal tube, that he was circulating the helium within? Oh, wait a minute. Oh, this is getting to be very interesting. But I don't know. I may be going way out on a limb here of tangential irrelevancies. Oh, dear, dear, dear. What if you could buy a radio tube filled with helium, of all things, at a local radio shop in 1931? Now what happens between the anode and cathode of your radio tube? Could be quite interesting. Oh my God. This is getting to be very interesting. Well, obviously this video has more speculation than anything else, but I do suspect the piston is building up an electrostatic charge because it's the whole shaft it sits on is at right angles to the magnetic flux of the two horseshoe laminates in Tesla special generators. So it's quite possible that the gas flowing across them is trying to dissipate that electrostatic buildup by turning it into an ionic conversion into ions, so as to help bleed off the electrostatic charge in a very safe manner. Safe for the FCC and safe for the crew members on board the ship. They don't want anything blowing up or igniting or, spontaneously exploding. I'm going to have to give this some more thought, but this is a very intriguing line of reasoning. What if helium is an unsung hero? How do they make helium? How do they collect it? Where do you go to find it? If it's a noble gas, it's not going to be in conjunction with anything. No kind of compound. Helium. I don't know. We make helium balloons, so obviously I've never researched this. This is going to be interesting. That's going to be my homework for tomorrow. If I get back the internet connection we've lost this evening, I'm going to look up helium. Try to find out where it comes from. Yeah, they sell us all those balloons in the supermarkets. Obviously, there's no shortage of this stuff. So maybe they have some way to reclaim the helium that gets lost to the environment. Continual recycling of the same body of helium surrounding us in the planet's atmosphere, the Earth's atmosphere. Oh my goodness. Still didn't explain where the load is connected to. Oh, so the idea was, if the shaft is merely providing an electrostatic charge, that could be the source of recharging the batteries. Which would help to deplete the electrostatic charge, but maybe not enough, without the compressed air helping it along. In order for that Okay, so there's still a lot of loose ends, and I'm not going to mention what they are. I'll just leave it at that. Anyway, this seemed like it was a productive video session, and I don't think I can come up with anything more. So maybe I better just sign off until my next inspirational breakthrough.